In this video, we are going to take a look at what to do when we are given a quadratic regression problem. A quadratic regression problem is typically going to give you a bunch of numbers. A lot of times it'll be in a table already, and your goal is to figure out the quadratic equation that matches that table. So what you're going to do is you're going to open up Desmos, which I have open to the left, and you're going to hit the plus sign and add a table. Once you add the table, you can input all of these values exactly as you see them. I'm going to save us some time. I actually already inputted them a second ago. And if you look at the graph, you'll see that it is given in the form where it's going up and then it's coming back down. So that's what is a clue to us that we're dealing with a quadratic equation. So what we're going to do is we're going to think of what the standard form of a quadratic equation is. If you don't remember, the standard form is y equals ax squared plus bx plus c. When we're finding the regression in Desmos, our equation is going to look very similar. The difference is that if you look at the top of our table, our variables are x1 and y1. So when we write it in to our next line, we're going to put a 1 after all of our variables, so it knows that it's going back to that table. And instead of an equal sign, we're going to put a squiggly line. So let's do that. We'll do y sub 1, a squiggly line, a x1 squared plus bx plus c. And you want to make sure you put the 1, which I left out. If you don't put the 1, just like you saw a second ago, you end up not getting an answer. Once you do this, it will give you the equation of that line. So where it says parameters a, b, c, those values get plugged in for a, b, and c in your quadratic equation. So I like to round to the nearest tenth. So it'll be y is equal to negative 5.2x squared plus 35.9x plus 0.4. Instead of putting the variables a, b, and c, I put the variables and what they were equal to instead. And then sometimes a problem will ask you, what is the height of the ball after, 6 seconds? So when it does that, what it's doing is it's saying, what is the height when x is equal to 6? So all we do is we plug in 6 for our x values. So we'll go to Desmos and we'll type in negative 5.2 times 6 squared plus 35.9 times 6 plus 0.4. So after 6 seconds, my height is going to be equal to 28.6 meters. That is all you do with a quadratic regression. A lot of the work is just done in Desmos, and you just have to plug the values in. If you have any questions, feel free to leave a comment, and I will help you as soon as I see it.